Hello guys, let's start with a new lecture on hypothesis testing. So, hypothesis testing is a statistical method that is used in making statistical decisions using experimental data. So, as we know, we are discussing about the inferential statistics, which deals with basically finding out what the population parameter could be. We're trying to estimate the population parameter. Okay, so for example, let's say you have every student in class 40, or let's say you have a hypothesis that the boy is taller than girl. So all the examples we assume some statistic to prove those. So let's say we assume that our hypothesis is that boys are generally taller than girls. But we need some mathematical conclusion, whatever we are assuming is true. So whatever statement we are giving, we should not give it as a blanket statement, but rather statistically prove it. So here comes hypothesis testing, which is an essential procedure in stats. And it evaluates two mutually exclusive statements about a population to determine which statement is best supported by the sample data. So let's say we say that height of boys is greater than height of girl, right? So this is our null hypothesis, right? This is our null hypothesis. Now we would collect some samples and statistically we would determine whether our hypothesis is true or not, whether we should reject our hypothesis or whether we should accept it. So basically, to conclude something, we need a formal testing procedure, right? And when we say that a finding is statistically significant, it is because of the hypothesis testing that we have done. So what could be the alternative hypothesis for this? H alternative could be height of boys is less than or equal to height of girls. Right? This could be the alternative hypothesis. And these kind of statements we are going to prove or disapprove using what is called hypothesis testing. Right? Let me clear it. Okay. So now basically, what are the important parameters of hypothesis testing which we should study? So the first one is the null hypothesis. So in inferential statistics, null hypothesis is a general statement or a default position that there is no relationship between the two measured phenomena or no association among the groups. In other words, it is a basic assumption or it can either be made on some domain or problem knowledge. So let's say a company is claiming that its production is 50 units per day, right? Or let's say in our earlier case, it was that height of boys are greater than the girl. So in this case, the null hypothesis will be 50 unit per day. And what is alternate hypothesis? Alternate hypothesis is a hypothesis used in hypothesis testing that is contrary to the null hypothesis. It is usually taken to with observations that are a result of a real effect with some amount of chance variation superposed. So when we collect a sample, we would definitely expect some variation, and hence we can form an alternative hypothesis in real world that okay, this is not equal to 50, saying that there could be some amount of deviation in the production rate. So it can be plus minus 50. This is our alternative hypothesis, right? Moving ahead, let's study what is level of significance. So this refers to the degree of significance in which we accept or reject the null hypothesis. See, 100% accuracy is never possible for either accepting or rejecting. So we have to have some amount of cushion, and this cushion is called a level of significance, which usually we keep as 5%. So we usually accept this 5% as our criteria, right? Uh, this can be also seen as a error criteria, So this is normally denoted by alpha. This is, we say that alpha is 0.05 and it is taken as 0.05 or 5%, which means that your output should be 95% confident to give a similar kind of result in each sample. So hence we give a tolerant of 5%. So 5% tolerance is there. Right. So this is what significance level is. Let's see about two kind of tests are there basically. One is one till test and the other is two till test. Right. So the boy's example, the height of the boy example which we gave was a one till test. Right. So let's study what is one till test. So a test of statistical hypothesis where the region of rejection is only one side of the sample distribution. So let's say this was the height. Let's say this was the height. We're observing the height here. So we would observe, we would have some samples. We would observe some heights during our experiment. And we would say that if our p-value lies here in this region, we would say that we could very well reject the null hypothesis. That means height of girls can be greater than height of boys. Similarly, if we are testing less than or equal to case, then we could go in this region. Now in the production unit example which we saw earlier, where the production was 50 or not equal to 50. In those kind of example, we could very well use this two-sided test. Now, what is this? In this type of distribution, what we say is there are two regions of exception or rejection. So alpha is 0.05 as we know, which is divided into two parts, right side and the left side. So extreme left and extreme right cases, if we are able to observe, if we are able to observe those cases, then we would definitely say that okay, we are going to reject our null hypothesis. Right. So this is called a two-tailed test in which the sample falls in either of the critical areas. Right. And if it falls here, then the alternative hypothesis is being selected. Right. So moving ahead, let's see what is p-value. We have been talking about it. So p-value or the calculated probability is the probability of finding. Let me move it down here. Is the probability of finding the observed or extreme results when the null hypothesis of a study question is true. So definition of extreme depends on how the testing is being held out, right? So let's say if the p-value is less than the significant level, the significant level is, as we already know, is alpha, which is 0.05. If it is less than this, we reject the null hypothesis, right? That is, except your sample gives reasonable evidence to support the alternative hypothesis. Right? So this is what p-value is. You are observing the extreme values. And if your p-value comes out to be less than or equal to alpha, then you straight away reject H naught. H naught is your null hypothesis. Right, so let's again rewind quickly the steps in the hypothesis testing. So we assume a null hypothesis, then we do some experiments, collect a sample, we do some test statistics, right, and then either accept or reject the null hypothesis. So these are the steps which are primarily involved in the hypothesis testing. Correct? Okay. So this is from the null hypothesis part. This is it from the hypothesis testing. Right. Now let's move on to see what hypothesis testing could be in using some Python. right? So here we have assumed, me annotate, use annotation. Okay. So here we have assumed our sort of distributions to be normal distribution. We are sampling from the normal distributions, right? And we have just simply plotted it, right? Later on we would see with the help of various tests, but now simply we have plotted it. So let's see what does this curve tell. So let's assume that this was our null hypothesis, right? Or let's say if we are talking about the height of boys, or let's say if we are talking about the production unit, let's say this was 50, right? This was our null hypothesis, 50 units per day. Now we did a sample, we did an experiment. We did an experiment in which we collected samples, right? And there what we observed was the mean was 60, right? Now we could very well see that these two distributions are very different, right? These two are very different distributions. Their mean, mode, median, everything is different, right? So if we apply any test statistic, let's say t-test, which we will be covering later, we could very well, sort of claim that we could reject our null hypothesis. Just looking at the distribution also, we can sort of claim this. But again, statistically, we would also see later using various tests that yes, we can reject our null hypothesis basis what our distribution looks like when we sample it. Okay, we would also be covering type 1 and type 2 error later. So that's it from this class. Thank you.